All right, hello again, everyone. For this video, we're going to be taking a look at cylinders and cones, and we'll be finding the lateral area, total area, and volume of those things. So let's jump right in and talk about cylinders first. Now, what you might notice about a cylinder is it looks very similar to one of the other solids that we've talked about, right? Cylinders are very closely related to prisms. The only difference being that cylinders have bases that are circles, whereas prisms had bases that were polygons, bases that were triangles or rectangles or squares or trapezoids or hexagons and all those other polygons, right? So if you keep that in mind, that circles are basically cylinders are basically circular prisms, it's going to be probably helpful in understanding a lot of the things that we're going to be working on. So some other terms that you need to know about cylinders. First of all, the altitude of a cylinder is a segment that's perpendicular to the planes containing the two bases. So it goes from one base to the other. It's basically the distance between the bases, right? That's what an altitude is. In a right cylinder, which is the only kind of cylinder we're going to be working with, there are other things called oblique cylinders, which are like kind of cylinders that are starting to kind of tilt over in a little ways. But in a right cylinder, the ones that we're going to be working with, the altitude will connect the centers of the bases. So you can see in my diagram over here, this segment right here connects the center of the top base to the center of the bottom. It's perpendicular to both. That is the altitude of this particular cylinder. So that is the altitude of this particular cylinder. The length of the altitude is what we mean when we talk about the height of a cylinder. It's the length of the altitude of that cylinder. So that's basically interchangeable with this idea of altitude. Height and altitude are basically the same thing. One last term you need to know for a cylinder, it's the radius of the cylinder. And the radius of the cylinder is basically just the radius of the bases. So each base is a circle. It has a radius, of course. That radius of the base is also what we mean when we talk about the radius of a cylinder. And those two measurements, the radius of the cylinder and the height of the cylinder, are all you need in order to find the lateral area, total area, and volume. So let's take a look at those formulas that are going to give that information to us. First of all, lateral area of a cylinder. Well, let's first remember that lateral area of a prism, lateral area of a prism was found by taking the perimeter of the base times the height. Cylinders are basically just circular prisms, right? So we actually do the same thing. It's basically the same formula, only it's going to look a little bit different because the perimeter of the base is the perimeter of the circle, right? The bases of cylinders are circles. Well, when we talk about perimeters of circles, we actually have a word for that, right? It's the circumference. So the lateral area of a cylinder will be, instead of saying the perimeter of the base, we are going to say it is the circumference of the base times the height of the cylinder. So it's essentially the same formula, only we're going to use circumference instead of saying perimeter. And we know how we find the circumference of a circle. We find the circumference of a circle by taking 2 times pi times the radius. So when we write out the formula for lateral area of a cylinder, you're probably going to want to write 2 pi r for the perimeter of the base or the circumference of the base, and you're going to multiply that times the height. So this right here, this is your formula for lateral area of a cylinder, 2 pi times radius times height. Now the total area of a cylinder, let's talk about that for a second. Remember, the total area for a prism was 2 times the area of the base plus the lateral area. And we're essentially going to be using that same formula. The total area of a cylinder, it's still going to be 2 times the area of the base plus the lateral area. Except, again, when we were doing prisms, what was tricky about this was that base could be a number of different shapes. And so we had to think about, okay, I need to find the area of the triangle if it was a triangular prism, or I need to find the area of a hexagon if it was a hexagonal prism. Cylinders always have circular bases. So finding the area of the base just means taking pi times the radius squared. So we can rewrite this total area formula. We can rewrite it this way, and this is probably what you're going to want to write down on your note card or your notes or wherever. You're going to write down 2 pi r squared, that's 2 times the area of the base, plus 2 pi r h. That's your lateral area formula, right? So you can see it's essentially the same formula that we use for a prism, except for we put pi r squared for capital B, and we put 2 pi r for 2 pi rh for lateral area. Now, volume of a cylinder, we're going to kind of continue the same idea. The volume of a prism was area of the base times the height. And guess what? We're going to use basically the same formula for a cylinder. We're going to take the area of the base and we're going to multiply it times the height. Except for the area of the base, we know the base is going to be a circle, so that's going to be pi r squared. So the volume of a cylinder is capital B times h, except for instead of capital B, we're going to write pi r squared, and then we're going to multiply it times the height. So let's put those formulas to use here in an example problem. We have a problem that says a cylinder has a lateral area of 70 pi and it has a height of 5. Find the radius of the base and the volume of the cylinder. So first off, we're going to start with this formula of lateral area equals 2 pi rh. And you can see there are 3 places where we could sub in a number. We could sub in a number for lateral area, for radius, and for height. If we want to find the radius, we better be able to put something in the other 2 spots, and luckily we can. We can put a 70 pi for lateral area, and we can put 2 pi times the radius times a height of 5. So now first let's simplify the right side of this equation. We'll have 70 pi equals, well, I can take the 2 times the 5 and make that a 10 and put it in front of pi rh. So I'll have 10 pi r. Now, what I'm going to do is I'm going to get rid of the pi by just dividing both sides by pi. Right? If I divide both sides by pi, we can see that it gets rid of that. And now I have 70 equals 10r. Well, that would tell us that the radius must be 7, because I can divide 70 by 10 and get 7. So now I have a radius of 7, and let's find the volume. Volume is pi times the radius squared times the height. So we're going to do pi times 7 squared times the height of 5. Now we're going to leave this in terms of pi, which means we're just going to simplify this side. So now we have pi times 49 times 5. And 49 times 5 should give us, let's see, 49 times 5, do that real quick on my calculator. I should get 245 pi for my volume. Now let's shift gears a little bit and talk about cones. Cones are related to pyramids. And you can kind of see that, I think, if you look at a cone. It kind of looks like a rounded pyramid, right? The bases of a cone are circles, whereas the bases of pyramids were polygons. Now, some other things you need to know about the cones. An altitude of a cone is a perpendicular segment from a vertex to the point on the plane that contains the base. Now, all we're going to be looking at are right cones. And in right cones, the altitude goes from the vertex, right? This point was the vertex in a pyramid. It's also the vertex in a cone. The altitude of a right cone is going to go from that vertex to the center of the base. So you can see this segment right here, which is going from the vertex down to this point that's the center of the base. That is the altitude of the cone. The length of the altitude is called the height. So that's the same as with cylinders, right? This would be considered the height of this cone. It's the length of that altitude, that segment that goes from the vertex down to the base. The radius of the base of the cone is what we mean when we talk about the radius of the cone. So there's a radius right there. And there's one other thing we need to know about a cone, and it's something called the slant height, which should sound familiar, right? We talked about slant heights when we were talking about pyramids, so it would make sense that they would show up talking about cones as well. It's the distance between the vertex of the cone and the edge of the base. So if you're looking at this cone right here, this distance right here from this point down to where the circle is, that is our slant height, which we're still going to use L for, but just to kind of make a note, that is slant height. So we have the altitude or the height, the radius, and the slant height of a cone. And those are the 3 things we need to know about a cone. in order to do the lateral area, total area, and volume. So let's take a look at those. The lateral area of a cone is equal to, now remember, the lateral area of a prism was 1/2 perimeter of the base times the slant height. But remember, we talked about in the cylinders, the perimeter of the base, that would be the circumference of that circle. And so we can use basically the same formula, only instead of saying perimeter, we'll think circumference, right? So it's equal to half the circumference of the base times the slant height. Remember, circumference of the base is 2 pi r. So the formula I would write down for lateral area of a cone is lateral area of a cone is equal to 1/2 2 pi r L. But we can simplify this a little bit, right? Because what's half of 2? It would be 1. So if we simplify this 1/2 and this 2, they basically cancel each other out. And we just get pi times the radius times the slant height. So lateral area of a cone is pi r L. Total area of the cone, remember total area of a, I said prism over here, I meant pyramid, sorry about that. Total area of a pyramid was area of the base plus the lateral area. And we're going to do the same thing for the total area of a cone, except for area of the base, we're going to put pi r squared, because remember the base is a circle. So total area will be pi r squared plus the lateral area, which we just found to be pi r L. So that's your total area of a cone formula. Volume of a cone, it's basically the same formula as volume of a pyramid. Remember, volume of a pyramid was 1/3 times the area of the base times the height. And we're going to use the same formula. Volume of a cone is equal to 1/3 the area of the base times the height of the cone. Area of the base, since the base is a circle, we know we're going to calculate that by doing pi r squared. So the volume of a cone is equal to 1/3 pi r squared times h. So let's look at one quick example problem. We have a volume of a cone that's 240 pi, and the height is 5. We need to find the lateral area and the total area of the cone. So I might want to do a quick sketch of this one. So pardon my drawing, this is not going to be the best, but it's just going to give us an idea of what this cone looks like, right? So we have an idea of what we're dealing with. Now the volume is 240 pi. Well, I can't really represent that on my drawing, but I can put the height right there at 5. Now from this, right, this is 1/3 of pi r squared h. So if I put a 240 pi where volume is, and I fill in 5 for the height, you can see I have a formula now. It's an ugly formula, but I have a formula that I can solve for the radius. So let's go about doing that. First of all, let's get rid of this 1/3 by multiplying the other side by 3. So 240 times 3 is 720. So now we have 720 pi equals pi r squared times 5. So next I'm going to divide by pi on both sides. That cleans up the pi, and now it looks a little bit cleaner. 720 equals 5r squared. I just rearranged that. Next I'll divide by 5. 720 divided by 5, let's see, that will be 164. Does that sound right? Let me try that on my calculator. 144, I was wrong. So that's going to be 144 for r squared, which would indicate then the radius would be 12, right? So now we have a radius of 12. We need that radius in order to find the lateral area and the total area, but there's something else we need, right? Because the lateral area of a cone is pi times the radius times the slant height. We don't have that yet. We were just given the regular height. But if I look over here, I have a right triangle that has legs of 5 and 12. And so if I want to find that slant height, I can go 5 squared plus 12 squared equals L squared. And you might be recognizing this as a Pythagorean triple. What I'm going to end up with is 169 is L squared. So 13 is my slant height. So now I can find the lateral area by doing pi times a radius of 12 times a slant height of 13. So now pi times 12 times 13 is going to give me 156 pi. My total area will be pi r squared plus pi rl. Now I know that this back part over here, I already know that's 156 pi since I just calculated that right there. So this part will be pi times 12 squared. Well, pi times 12 squared is going to give me 144 pi. And I'm going to add that to 156 pi. And I can kind of think of the pi like an x, so I can combine these like they were like terms. And what I'd end up with is 300 pi. Okay, folks, that's about it for this video, so I will see you next time when we talk about spheres.